Hey class, this week we're looking at product development and whether or not you should develop a particular product. So just to recap our discussion, there's this generic new product that you are thinking about developing, and there's a 60% chance that it'll be a success on the market, which clearly means that it's a 40% chance that it'll fail. Now, if it is a success, you'll get a profit of about $200,000. And if it's a failure, you'll incur a loss of $100,000. So the question I'm asking is, should you develop this product? Also, how do you make your decision? And how can you come up with the probability of success or failure? Now, clearly, most of you guys have looked at this product, this problem, and realized that this has something to do with the chapter we're in. So you looked at the expected value formula. So to be clear, if you look on page 539 of your textbook, it tells you what the expected value actually is. So suppose that a random variable x can take on the n values x1 and xn. What does that mean? Well, we know a random variable means that it can take on more than one possibility. In this case, there's a success probability and a failure probability. So when we say it can take on n values, in our case, n is equal to 2. So n is equal to 1 would be success, and n equals 2 would be failure, right? So now we know that we have two options for this particular random variable. And it says, suppose also the probabilities that these values occur are p1, p2, etc. Then the expected value of the random variable x. Now, x is said to be a random variable because you don't know if you in fact will succeed or fail. But it's going to equal the value that you expect to get times its probability. Okay. So in our case, it'll be x1 p1 plus x2 p2. Now you'll notice in our discussion boards, you plugged in 200,000 for x1, and you plugged in negative 100,000 for x2, because if you fail, you actually lose money. So if I were to take this out, you'd see the expected value of x is equal to 200,000. Okay. Now the probability of getting 200,000 was 0.6, right, 60%, plus a negative, so it's basically minus 100,000 times 0.4. And if you were to do the math here, you'd see you'd have 120,000 minus 40,000, which is 80,000, which many of you guys got, and came up to the conclusion that you should in fact develop the product. But I wanted to kind of discuss this for a minute, just to kind of give you guys a different way of looking at it. So let's consider this problem a little bit closer. So from a naive point of view, as long as our expected value is positive, then the odds are on your side that you will not lose money. So that's probably why most of you guys said that there's the decision to develop, because you're going to earn money, generally speaking. However, this methodology alone has several limitations, and I'll describe two. One of them is a mathematical limitation, and the other one is a practical limitation. So I'm going to give you the practical limitation first. Okay? So we have at least two reasons why you should be leery of just using that expected value. Okay? So practically speaking, decisions should be made based on data, but not data alone, right? So, there's no mention as to the health of the company. Okay, can it sustain a $100,000 loss if it does happen? What kind of industry is it in? And what about the competitors? Is there a mitigation strategy in place in case this thing blows up? One thing I didn't see a lot of this term was the length of time it's going to take before you realize your $200,000 profit. Can you stay solvent until your checks start rolling in? Can you sustain yourself until payday rolls by? Do your customers need your product, or is it some type of fad that it's just kind of here today, gone tomorrow? Do they actually want it, et cetera, et cetera, et cetera? Now, you were at liberty to make your own assumptions here, and hopefully you did make some of the assumptions and can defend it if you have to. Okay. Now, mathematically, there are several considerations. Number one, okay, if you look at a 60%, uh, 60% is not that high. If you think about it, it's a 6 and 10. That's just one better than a coin toss. I mean, a coin toss is 50-50, right? So, or 5-5. So a 60% proposition is just one more here, right? So you're at 6-4. Are you comfortable dropping $100,000 on a heads or tails decision? Now, some in the business world will say that a 60% success rate is good when it comes to product launch. Now, me personally, I'm a little bit more conservative than this, and I need much better odds to plump down that kind of loop. But what I want you guys to take away from this week's discussion is this: the interpretation of probability, and this is another reason why I want to have this video for you. The interpretation of probability is what happens with repetitive iterations of an event. Okay, so probability, in a strictest sense, is repetitive iterations of an event. Okay, in our case, the event is the launch of this product, or generally speaking, the random variable. The random variable can take one or two, right? Which in our case is a success or a failure. But from a probability standpoint, it's the repetitive interactions of iterations of an event. If I could spell, I'd actually put iterations here rather than iterations. There you go. So, example, it's the long-term odds of success. That's another way you can think of it. So we can say the long-term odds of success. Okay. And I'll give you some concrete examples in 1 minute. So how can we use this probability idea? Okay. If you think about, if you were to launch this product 1,000 times, right, you would be successful 600 times on average, and you'd fail about 400 times. Now, if this happens, your expected profit would be 80,000, which we calculated last time, times n, however many times you actually did launch the product. Okay? So over a long time, your cumulative success rate will converge to 60%. But it's not 60% for any one iteration. So what do I mean by this? Okay, and I'll have to give you an example just so you can kind of get a feeling as to what we mean by this. Okay, so in the first time I launch this, I either succeed or I fail. Okay, let's say I fail. Okay, I'm at 0%. The second time I launch it, let's say I succeed. Okay. So now 1 out of 2 leads me to a 50% success rate. Okay. Let's say the third time I launch it, I succeed. Okay. So now I have 2 positives and 1 negative. I'm at a 67% success rate. Fourth time, let's say I fail. Okay. 2 and 2 brings me down to a 50%. Right. Fifth time, let's say I succeed. Okay. 3 out of 5, 60%. Okay. So you can see over time, okay, the graph of your success rate. If I were to actually put up the success rate graph, it would kind of oscillate like this and come to a steady state right around 0.6, which is the 60% success rate. And this is how many times you actually launched your product. So 1, 2, 3, dot, dot, dot. Okay? So that's what we mean by the long-term success. Now look at any one time that you actually try to launch the product. Like this first time, for example, that's a 0%. Okay? What if the first time I launched it, I actually had a plus, which means I was successful? Then I'd have a 100% success rate. So you'll see for any one launch of this product, it's not 60% success. It's 0% or 100%. And it's just that simple. So, if you think about it, it would be nice to launch this product 1,000 times. You could think about it like this. Let's say I'm launching this product in 1,000 cities at the same time, and hopefully 600 are going to be successful and 400 you're not. But that's not beneficial or realistic. Okay? The truth is, you're going to launch this thing once. Okay? Flip a coin. Are you feeling lucky? Because that's what you have. It's either 0 or 100%. But that's why it's important to consider other business conditions before making a solid decision. Just looking at the math, which is what we did here, won't get you there. Okay? So I just want to kind of let you know, for this week's discussion, there was no right or wrong answer. It's not, you said you'll develop it, so you're wrong. Or you said you won't develop it, so you're right. There is no right or wrong answer here. But we just want you to, at least I just want you to see that the probability, by definition, is the long-range success rate. Okay? Any one iteration of this event, it's either a yes or a no, 0 or 100. You gain 200,000 or you lose 100,000. And in our case, the question becomes, can the company support a loss of $100,000? And for reasons that you guys brought all week long, if it's a established company, maybe they can eat $100,000 loss. If it's a startup, maybe they can't, or maybe that's what the purpose of the startup is, to just go for broke and hope it works out. And me personally, like I said, I'm too conservative. I would not take this deal. So hopefully you guys enjoyed the discussions this week, and I look forward to talking to you guys soon. Take care. Bye.